here's the shocking reality about rocket science that even Elon Musk openly admits. Building a fully reusable spacecraft is an insanely hard problem that has never been solved before. But after a devastating series of explosions and failures, SpaceX just achieved something remarkable that brings us one step closer to becoming a multiplanetary species. On Tuesday evening, SpaceX's colossal Starship rocket system finally delivered the breakthrough the company desperately needed. The towering 400-foot behemoth, a combination of the Starship spacecraft and its super heavy booster, successfully completed its 10th test mission, marking a crucial turning point for what could become humanity's ticket to Mars. Launching from SpaceX's Starbase facility in South Texas at 7:30 p.m. Eastern Time, the uncrewed vehicle roared to life with 33 powerful Raptor engines, generating an earth-shaking 3.3 million pounds of thrust. But here's where it gets interesting. This wasn't just another routine test flight. For the first time ever, Starship successfully deployed actual payload simulators resembling next-generation Starlink satellites during its suborbital journey. The spacecraft also managed to restart one of its 6 engines while in space, 2 critical capabilities that had eluded previous attempts and are absolutely essential for future orbital missions. And this is the part most people miss. Unlike the string of premature endings that plagued earlier flights, this mission concluded exactly as planned. Starship executed a controlled landing burn and splashed down safely in the Indian Ocean, west of Australia, roughly an hour after departure. A floating camera captured the dramatic splashdown, which included an expected explosion as the craft hit the water. A normal occurrence since Starship isn't designed for ocean landings and will eventually return directly to the launch pad. Meanwhile, the Super Heavy booster took a different path, performing its own controlled splashdown in the Gulf of Mexico, rather than attempting the spectacular chopstick catch maneuver used in previous tests. Despite losing one engine during descent, the booster landed precisely where intended. But here's where the story gets controversial. This engineering triumph came at an enormous cost in both money and public confidence. The road to success has been littered with spectacular failures that would make most companies reconsider their approach. Just 2 months before this victory, a Starship literally exploded on the launch pad during routine pre-flight testing while loading super cold propellant. SpaceX's investigation revealed that a pressurized nitrogen tank failure triggered what the company diplomatically called a sudden energetic event, completely destroying the vehicle and damaging surrounding infrastructure. That June explosion followed closely on the heels of the 9th test flight disaster, where Starship experienced what SpaceX euphemistically termed a rapid unscheduled disassembly. Industry speak for a catastrophic explosion during flight. The first stage booster was also lost when unexpected structural forces caused it to explode during its Gulf splashdown. The 8th test flight in March ended similarly when a Raptor engine malfunction caused fuel to ignite in the wrong place, triggering an automatic self-destruct sequence. Debris scattered across South Florida and the Atlantic Ocean, forcing temporary closures at nearby airports and raising serious questions about public safety. January 2025 brought yet another setback when excessive vibrations during the 7th flight caused propellant leaks that led to another explosive loss of the spacecraft. Now here's what makes this approach so divisive. SpaceX intentionally pushes these vehicles to their breaking points, even removing critical heat-resistant tiles from vital areas to test failure modes. This aggressive, fail fast, learn faster philosophy is central to their rapid development cycle. But critics argue it's recklessly dangerous and wasteful. SpaceX CEO Elon Musk defended this strategy on social media, acknowledging the immense challenge There is a reason no fully reusable rocket has been built. It's an insanely hard problem. Moreover, it must be rapidly, completely reusable, like an airplane. This is the only way to make life multiplanetary. But here's the reality check that nobody wants to discuss. SpaceX still faces massive hurdles before NASA will trust them with human lives. Before any astronaut set foot aboard Starship, the vehicle must undergo NASA's rigorous human rating certification process. This comprehensive evaluation examines every aspect of safety, reliability, and suitability for human spaceflight. NASA demands proof that the spacecraft can survive failures, maintain life-supporting conditions, and provide crew members with adequate control and situational awareness. The standards are unforgiving. NASA requires spacecraft to be safe enough that the probability of losing a crew during launch and landing operations remains below 1 in 500. Achieving this certification means Starship must position this multiplanetary expansion as essential for humanity's survival, stating that rapidly reusable, reliable rockets is the key. But is this timeline realistic, or is it dangerous overpromising? Each successful mission, like Tuesday's flight, certainly brings that vision closer to reality, as engineers gather crucial data about what's needed to make interplanetary travel feasible. However, the gap between single successful test flights and routine daily launches carrying human passengers remains enormous. The fundamental question that sparks heated debate in aerospace circles is whether SpaceX's rapid iteration approach, learning through expensive failures, is the fastest path to Mars, or whether more traditional, cautious development methods would ultimately prove safer and more cost-effective. What do you think? Is SpaceX's blow things up and learn from it approach the revolutionary thinking needed to make humanity multiplanetary? Or are they taking unnecessary risks with public safety and taxpayer-funded contracts? Are we witnessing the dawn of a new space age? Or is Musk's Mars timeline nothing more than ambitious marketing? Share your thoughts. This debate is far from settled, and your perspective matters in shaping the future of human space exploration.